Hey guys, I'm Loring Harkness, head of commercial at BrainBot, one of the core technical developers behind Shutter Network.
Hello, I'm Yannick. I guess I'm representing the tech side of the project.
Let's play a game. Can I get a volunteer? Hands up. Who wants to join me up on stage to play a game? Yes. There were many hands, but you got yours up first. Yes, give him a round of applause. What's your name?
Philip.
And have we ever met before, Philip? No. Okay. So, the game we're going to play today is rock, paper, scissors. The rules are complex. You need to show rock, paper, or scissors on the count of 3. Do you understand?
Yes.
Okay. You'll be playing against Yannick over there.
Okay.
So step right up. And to make things super official and fair, I'm going to count. Are you ready?
Yes.
1, 2, 3. Actually, you guys showed on 4, but you both did paper, so we've got an instant rematch. Okay? Show on 3. 1, 2, 3. Let's do it again. 1, 2, 3. Ah, Philip, you won! Congratulations! Give him a round of applause. Okay, now we're going to introduce a small change to the traditional rock, paper, scissors. It's called information asymmetry. So Philip is going to show his hand, and then after he's committed to his hand, Yannick will be free to show his hand. Okay? Let's get started. 1, 2, 3. Oh, yes. Philip, you lost. Give him a round of applause. Thank you, Philip. I wish we had a prize for you. You were such a great sport. Now, in a game where one player shows their hand, and then the other player shows their hand with prior knowledge of their opponent's move, then the one with prior knowledge will win every single time. And it's a stupid fucking game, right? It's no competition at all. But we play this game all day, every day, on chain. Give you a moment to enjoy my meme. When I hear chuckling, I will continue. Yes?
I have a short question. Isn't that what the EU just made illegal? Trading based on mempool actions? Or about to?
We might get into policy discussions in a little bit. Let me continue. So here we have all of these situations where people do really stupid things. And then in the final brick, we have 2 people who say, let's submit our transactions, or more accurately, our unencrypted transactions, to a public mempool. So when you submit an unencrypted transaction to a public mempool, you're basically showing your hand and letting other players on-chain take advantage of that knowledge. And they can do a couple of really malicious things. One thing they can do is front run or sandwich you. And this is basically pretty simple. Alex submits her transaction, let's say to swap some tokens. And Bob comes in and with that knowledge, slides in a transaction before Alice's transaction, thereby driving the price up or down. And then a transaction immediately after Alice's transaction, benefiting from the trade. So in this case, Alice is actually losing money because of this sandwich attack. Similarly, censorship. If a validator can see the contents of a transaction, then the validator can simply refuse to include that transaction in the block. And that, in the best case scenario, may lead to delays. But if there's enough validators which are censoring transactions, then the transaction may not ever be included. So what we need is we need new rules. And we're not going to wait for regulation. We're going to have a technology solution. And with that, I'll hand it over to Yannick.
Thank you. Yeah, so first of all, who's building the technological solution? It's not just us. It's Shutter Network, it's also Gnosis chain, and it's Nethermind, who's maintaining one of the main clients on Gnosis chain. So how do we fix this problem? We use encryption. We allow users to encrypt their transactions and only submit it in this encrypted form. This means when they send the transaction, they don't release any information to other people. By that way, we basically get rid of this information asymmetry. Person that includes the transaction, in theory, they can still front-run the transaction. They can still put other transaction before or after the transaction, but they can't do so using the knowledge that's in the transaction or the information that's in the transaction. So effectively, the best they can do is order, for example, by arrival time. And using that way, Alice is not harmed anymore. The encryption part is very easy to build. The more complicated part is the decryption. Because once the transaction is included, we have to, in order to execute it, we have to decrypt it. The naive way to do that would be to ask the user to do that, to release the decryption key so that everyone that validates the chain can decrypt and execute it. But this would be very annoying. First of all, the user would have to send 2 messages to the network whenever they want to do something. And also the user could decide, I don't want to reveal my transaction now because I don't like the result. And they collectively perform the decryption or perform the decryption key generation. We have a majority assumption, an honest majority assumption here. So as long as the majority of the nodes is honest and behaves as we tell them to, or as the protocol tells them to, then they will generate keys at the right point in time and don't peek into transactions too early. And the members of this committee is selected by a DAO, and the DAO will make sure that they come from different backgrounds and that the set is large enough so that collusion becomes very difficult to do, so that this honesty assumption is actually justified. So that was kind of the main principle behind it. I want to talk a little bit about the implementation, but keep it very short. The main thing I want to highlight is our guiding principles for this implementation, because changing blockchain protocols is always very difficult and very risky. So we try to make it as safe as possible without breaking things if for some reason the protocol doesn't work or if there's unexpected issues. So the implementation guidelines here were we don't want to do a hard fork. We want to have the complexity as small as possible. We want to have good user experience, so users should not be negatively affected. And we want to be able to iterate from there. So we want to be able to improve the protocol over time from then. Less important is like the perfect solution in the very beginning. So we don't mind if there's still some trust assumptions in the beginning, as long as we know that we can get rid of them in the future. We have a keeper-side manager contract. That's basically just a contract that's owned by the Shutter DAO that selects keepers for this protocol. Once these keepers are in that contract, they will start a distributed key generation protocol. It's like a somewhat complicated cryptographic protocol, but the main point here is that they produce 2 types of keys. One, an encryption key in the very beginning, and every user will use this one key to encrypt their transaction. And then for each transaction later, for each block basically, they will produce decryption keys. So every transaction then gets its own little decryption key. This encryption key, we call it the Eon key, because it's valid for a very long time scale, is broadcasted via a contract. So people who want to encrypt just look in the contract and check which key they should use. Validators. So ideally, all validators participate in this protocol, for example, definitely. This would be the case, for example, if we would do a hard fork, if we would require participation. But in the beginning, we want to make this optional so that people who are don't want to accept this risk and maybe are a little more conservative, they don't have to participate here. But if they want to, they register in a contract, and only those will have to follow these additional rules. This is kind of the flow how it will look for the user. The user will encrypt their transaction locally, so no one will have seen it at this point. They will send it to a special contract, the sequencer contract. The keepers will then look in this sequencer contract, see which transactions should be decrypted now, once they already included in the chain, so they can't be reordered anymore. They will produce the decryption keys, publish them to the network. The proposers will then take these keys, decrypt them, build blocks. Very simple. For the user, this is unfortunately in the very beginning. Of course, they don't want to do the encryption manually, so we want this to be integrated in either in dApps, front ends, or in wallets. This is unrealistic in the beginning, so what we build is an encrypting RPC server. So to use this encryption feature, they just have to switch to the RPC URL to one of those, and then this performs the encryption. They have to trust it, but at least it's much easier and and minimal UX impact. In the very beginning, as I said, there's some trust assumptions involved. In particular, there's no checks on the validator. If the validator doesn't follow these rules, if they, for example, don't include a transaction, then there's no punishment or anything. This is something we want to change. So we want to slash them once we know that we have proof that they didn't follow the rules. And in the very far future, maybe even make these blocks invalid so that these blocks will just be ignored then. And also for the keepers, we want to make misbehavior on their side a bit more expensive. We want to make them require staking so that we have money that we can slash if they misbehave. And there's also some fancy cryptographic solutions that we might be able to use. Yeah, that's all from the tech side. Happy to talk more about it later because I realized it was quite fast. But back to Loring.
So if you'll indulge me, I'm going to share with you one of my favorite videos about how to build a movement.
If you've learned a lot about leadership and making a movement, then let's watch a movement happen start to finish in under 3 minutes and dissect some lessons. First, of course, a leader needs the guts to stand alone and look ridiculous. But what he's doing is so simple, it's almost instructional. This is key. You must be easy to follow. Now here comes the first follower with a crucial role. He publicly shows everyone else how to follow. Notice how the leader embraces him as an equal. So it's not about the leader anymore. It's about them, plural. Notice how he's calling to his friends to join in. So it takes guts to be a first follower. You stand out and you brave ridicule yourself. Being a first follower is an underappreciated form of leadership. The first follower transforms a lone nut into a leader. If the leader is the flint, the first follower is the spark that really makes the fire. Now here's the second follower. This is a turning point. It's proof the first has done well. Now it's not a lone nut and it's not two nuts. 3 is a crowd and a crowd is news. A movement must be public. Make sure outsiders see more than just the leader. Everyone needs to see the followers because new followers emulate followers, not the leader. Now here come 2 more people, then 3 more immediately. Now we've got momentum. This is the tipping point and now we have a movement. As more people jump in, it's no longer risky. If they were on the fence before, there's no reason not to join in now. They won't stand out, they won't be ridiculed, and they will be part of the in crowd if they hurry. And over the next minute, you'll see the rest who prefer to stay part of the crowd, because eventually they'd be ridiculed for not joining. And ladies and gentlemen, that is how a movement is made. So let's recap what we've learned. If you are a version of the shirtless dancing guy, all alone, remember the importance of nurturing your first few followers as equals, making everything clearly about the movement, not you. Be public, be easy to follow. But the biggest lesson here, did you catch it? Leadership is overglorified. Yes, it started with the shirtless guy, and he'll get all the credit, but you saw what really happened. It was the first follower that transformed a lone nut into a leader. There's no movement without the first follower. See, we're told that we all need to be leaders, but that would be really ineffective. The best way to make a movement, if you really care, is to courageously follow and show others how to follow. When you find a lone nut doing something great, have the guts to be the first person to stand up and join in.
So why did I play that video? For the past few years, as we've been building Shutter and talking about our vision for preventing malicious MEV and censorship using encrypted mempools, we've often felt like that lone nut, that shirtless dancing guy. And we are so thankful for Gnosis and the Gnosis community to step up and show leadership by embracing this vision. And our hope is that when we launch encrypted mempools on Gnosis chain on July 11th, that the implementation will be successful. And it will reduce the barrier of entry, the risk for other chains to embrace encrypted mempools as well. And our hope, our vision, is that with each chain that protects its users against malicious MEV and censorship using encrypted mempools, that it becomes easier for the next one and the next one and the next one to follow. And hopefully, we can protect users all across different chains, no matter where they happen to be trading or transacting or playing. But I also wanted to play the video to encourage you to join Shutter and join the movement, because we think of Shutter not just as a project or a technology. We really think of it as a movement for base layer neutrality, information symmetry, and accessibility. Some of those core values which many of us, hopefully all of us in crypto, hold so dear. Shutter on a technology level is this general commit and reveal gadget which can be used for lots of different applications, including shielded trading, which is what we've been talking about in this presentation, shielded voting, which is currently live on Snapshot for DAO voting, and shielded gaming, something that we're working on for the future. So if you are into technology, if you're a developer, please do contribute. And here's a couple of great ways for you to do so. Number one, Shutterized Chiato testnet is currently live, and there is a swapper pool. So please test out Shutterized Swapper on Chiato testnet. It's a great way for you to get a feel how encrypted transactions work. If you are a wallet or a dApp developer, please get in touch with us. We would love to talk with you about how you can natively support encrypted mempools on Gnosis chain. And if you are a validator, please get in touch with us to learn more about encrypted mempools as implemented in the Nethermind client. And if you scan this QR, you will be taken to a validator expression of interest form. It basically has a bunch of optional questions asking a little bit more about who you are and how many validators you run. And hopefully we can get some contact information so that we can start a conversation and onboard you to the Shutterized Nethermind client. And for everyone in the room, if you could help us spread the word, that would be awesome. If you add the shield and swords to your Twitter profile, that's kind of a code to let other people know that you hold these same values. Please help us amplify the narrative that malicious MEV is theft. It's something which crypto has permitted for far too long, and it's time we change the narrative. And of course, if you're not a developer, engage your favorite dApps and wallets, asking them to include Shutter as well. We're also doing a survey of Gnosis chain users, specifically people who have done a token swap on a DEX or an aggregator on Gnosis chain between March and May 2024. And if you complete this survey, it's very short, I think 5 questions long, then you will be eligible to win up to 500 USDC in a lucky draw, which we will hold on, that should be 2nd July, and the lucky draw will be a day later on 3rd July. Thank you very much. It's been a pleasure introducing Shutter. And if you do have questions, do we have some time?
Yes.
Okay, wonderful. Philip.
What curve for the crypto are you using?
BLS 12381.
So is there a way for you, or are you already compressing multiple transactions into one message on the encrypted mempool? Is that something you do?
No, we don't do that yet. So I'm not sure if that's what you're asking, but there's basically two ways we can do this encryption protocol. So it's not like signature aggregation. That's like a...
No. But you could maybe use Merkle trees and then plus the BLS aggregation of the signatures. I don't know how the mempool is in detail structured, but there's probably some possibilities, right?
Yeah, so we need to get all the transactions in there because they have contained the information that the chain needs to execute them, so we can't compress much there. What we can do is we can use the same keys for multiple transactions. And
so as a use case, what I'm thinking about is you are an exchange or some kind of company and you want to have multiple transactions, but you're able to commit them all in one encrypted message, and that would be, in my mind, beneficial for you then to compress it down in some way, right?
yeah, so we don't have anything specific there, but we support all transactions that are accepted by the chain. So you could do like a multi-call transaction and encrypt that. So that could work.
Okay, thanks.
Thanks for the presentation. So 1 year ago, I think, in SafeDAO, we had this discussion on centralization of the Keeper Committee. Haven't followed that much ever since, but what is your argument between the benefits, which you've outlined very well, on the one hand side, and the other hand, potential risks of centralization? And you do say you have trusted, selected keepers, and that sounds like a pragmatic way forward, but still the argument stands, I think, in many protocols, they do not want to, Pareto optimally decide to go better rather than worse in sense of centralization. What's your argument here?
Yeah, good question. I think I wouldn't call it. I wouldn't say that they're trusted because there's still like a kind of a protocol-defined process how the keeper set can be changed. So because we have this DAO that does the selection. Yeah, of course we don't want to have like a centralized set. And that's why we want to choose the size of the set as large as possible. And the larger it is, the less centralized and the less controlled it becomes, hopefully. Yeah.
In addition to that, we're introducing staking and delegated staking as an economic security model where basically all of the keepers will need to put an SHU stake down as a guarantee that they will not, in fact, collude or be at risk of slashing if they do. We're also exploring a technology which we call Shutter with snitching, which is basically a way to detect collusion among keepers and then either penalize or blacklist the offenders. Are there any other questions? Well, thank you so much for having us today. And thank you again to Philip for playing our little game with us.